Good morning, everyone. We're going to talk about the first derivative test today, and this is topic 5.4 in our AP Calculus sequence. And this really just builds off of what we learned in 5.3 about increasing and decreasing functions. You can see here at this function we've got drawn, it is decreasing here, so it has negative slopes to the tangent line. Over here, it is increasing, so it has positive slopes to the tangent line. When a function changes from decreasing to increasing, this is a maximum according to the first derivative test, when the derivative changes from negative to positive. So if we have derivative values, notice that these are derivative values, changing from negative to positive, then we have a minimum. If they change from positive to negative, then we have a maximum, and that would be illustrated right here. These are changing from positive to negative. So let's look at this example. Let f of x equal this function for which x value or values does f of x have a relative maximum. So the first thing we should do is find the derivative, which is x squared plus 2x minus 48. Let's set it equal to 0. That's what we always do. We are looking for critical points when we do this. Okay, this is our critical point step. This thing factors nicely into x plus 8 and x minus 6. So that means our solutions are x equals negative 8 and x equals positive 6. So what we're going to do is make a simple number line. We're going to put positive 6 over here, negative 8 over here, and we're going to try values of the derivative to the left and right of these. So we'll try f prime of negative 9, we'll try f prime of 0, and we'll try f prime of 7. F prime of 0 is easy. That's negative 48. So in this area, we have a negative value for our derivative. When I do f prime of 7, you can see that we're going to have 49 plus 14 minus 48. So that's going to be 15, which is a positive value. And over here, I'll save us some time. This one is also going to be positive because we have 81 minus 18 minus 48, which is still a positive 15. Okay? So this is positive. So if you look at what we've got going on here, we're looking for where we are changing. Go back to what we just learned. We want to change from a positive to a negative for a maximum, something like this right here. And so that happens right here at negative 8. So this is the location of a maximum. But notice, we're told to justify our answer. Now, the x value of the maximum is negative 8. Okay? So the x value is negative 8. The actual maximum happens at f of negative 8, which I'm just going to tell you that value. It's 847 over 3. This is the actual maximum value. All right? So to justify this, though, we cannot use, this is called a sign chart. The College Board does not accept a sign chart as justification. We have to make a statement about how the derivative is changing from positive to negative. All right? So a correct statement would be one like this. Negative 8, 847 thirds is the location of a local max because f prime of x changes from positive to negative at x equals negative 8. And it would be a similar statement for the minimum. All right? Let's take a look at this problem. The graph of f prime, the derivative of f, is shown below. identify the x values of all the critical points, and determine whether f has a relative maximum, relative minimum, or neither at those values. So we're looking for where is f prime of x equal to 0. So that's here, here, and here. So we have -3, we have +3, and we have 8. Well, but there's only 2 of those where there is a sign change. At -3, we are changing from a negative slope of the tangent line to a positive. And over here, we are changing from a positive to a negative. So at these 2 locations, we've got extrema. All right? And when I change from a negative to a positive, that has to be a minimum. So x equals -3 is a minimum location. Here, we're changing from a positive to a negative, so this is a maximum. And here, there's no sign change, so there's no extrema there. All right? Let's look at this problem. Let f be a differentiable function defined whose derivative is given by f prime of x. Notice it's only for x is greater than 0. Find the x-coordinate of any critical point and classify it as a relative min, max, or neither. So once again, we're given the derivative. That makes it easy. So we're going to set the derivative equal to 0 and solve it. Obviously, this term goes away. The denominator goes away when we multiply both sides by it. So we have x minus 4 and x plus 4 equal to 0. So we get x equals 4, x equals -4. But this one gets ruled out because it's not in the domain. So we're only interested in this one. So all we have to do is check values to the left and right of 4 in the derivative. So we can check f prime of 5. We can check f prime of 3. F prime of 5 is going to be 25 minus 16 over 7. That's going to be positive. F prime of 3 is going to be 9 minus 16 over 5. That's going to be negative. So we are changing from a negative to a positive. At this value, because we're changing from a negative to a positive, then this has to be a local or a relative minimum. Again, because of the sign change. On this last problem, for what value of k does this function have a maximum of 10? Well, we need to take the derivative, f, and we notice that it's a cubic. F prime of x will be 3x squared minus 12x plus 9. The derivative of this k is 0, so it just goes away. All right? So what we do is we set this equal to 0 and solve it, and I can see that I can take a 3 out to make it a little bit easier. X squared minus 4x plus 3. The 3 goes away, and we have x minus 3, x minus 1 as extreme values. So 3 and 1 are locations of extrema, all right? But we're asking, when is the relative maximum 10? Let's make this easy. Let's plug in 3, okay, into the function. So we've got f of x equals x cubed minus 6x squared plus 9x plus k. We want it to equal 10 when I plug the value in. And I've got 2 choices here. We may as well do the easy one first. Let's do the 1. Put in 1 cubed minus 6 times 1 squared plus 9 times 1. And that's plus k. And we have 10 equals 1 minus 6 plus 9 plus k. That's negative 5 plus 9, which is 4 plus k. K could be 6, but you know what we didn't check? We didn't check to see if this was a maximum or a minimum anyway. All right? So we need to check values to the left and right of that. What is f prime of 0 and f prime of 2? F prime of 0 is going to be positive 9. F prime of 2, I'm sure, is going to be a negative value. That's going to be 3 times 4, which is 12, minus 24, plus 9, which is negative. So we're changing from positive to negative. 1 is the location of a maximum, because remember, if we've got a maximum, we're changing from positive to negative. So this is our maximum. So we're okay. Our process is done. We have found the k value, and we have confirmed that this was a maximum. And we will stop the video there for today.